طيب بسم الله الرحمن الرحيم. So last time we started to talk about SYSMA or carrier sense multiple access, and we started to talk about the persistence strategies. We talked about the one persistent where the node keeps sensing the channel and immediately sends once the channel becomes idle. And we have talked about the pros and cons of this in terms of the high overhead and the high probability of collision. Then we talked about the non-persistent, which tries to take the opposite approach by sensing the channel every so often, which minimizes the overhead, however, and reduces the collision. However, it misses some chances to access the channel whenever the channel is idle. And then we talked about the compromise between the two when we use the P persistence. For the case of P persistence, we sense the channel, and then once the channel becomes idle, we send with the probability of P. So we generate a random number, and then if it's less than P, we send. If it's more than P, then we wait for a time slot, and then we do the same. So today, inshallah, we'll talk about the characteristics that happens on the shared medium whenever a collision happens. So we'll talk about very important parameters when the collision happens. So for example, here, the classical scenario for collision is that when A sends the first bit of the frame over the shared medium, it's sent at time t1. However, node C, because of the propagation delay, listens or hears that transmission at this time, t3. Okay, so if node C senses the channel at time t2, then it finds the channel idle, right? Although the channel is not actually idle because of the transmission from A. So C might actually try to send and the collision happens. So carrier sensing does not actually eliminate collision by any means. It tries to reduce it, but not necessarily eliminate it. So that's a classical scenario for for motivating the fact that carrier sensing does not, in fact, eliminate collision. But if I go back to our famous graph here, the space-time graph here, if it happens, مثلا, that a node exists, مثلا here, node E, this node will detect the collision the earliest, right? Because the collision first happened here. It happened in this time and space, exactly. So when the node here senses the channel, it should detect that collision, and we'll tell you how. We'll tell you how it detects that collision now. Okay, so once this node detects the collision, it should send a jamming signal. Any node detects the collision, it will send a jamming signal. Is now when A tries to send, usually, especially for wired networks, when A tries to send, so here we're talking about SYSMA CD. We're talking about carrier sense multiple access with collision detection. This happens in wired or wired networks. Wired قصدي or wireless networks. This happens in wired networks or wireless networks. Yani anyone can answer this question. Wired networks, right. So we can only detect collision in the case of wired networks. Type. So this means that when A starts to send the frame, okay, the frame will propagate through the line at the same time, okay. C, when it tries to send and the collision occurs first here, but this transmission from C will be listened to at A at this point of time. The question is now, if A, when it sends, it detects that there is a collision happened at time t4, what should it do? Should it continue transmission, okay, of the frame, or should it stop? What is the logical thing to do here? If A detects the collision at time t4, should it continue sending, okay, or should it stop? Logically, what should happen here? Stop. يعني there is no, yeah, logically, if A continues to transmit after it detects that there was a collision, okay, actually, from the beginning, the whole frame is wasted. Okay, there was a collision and the whole frame is wasted. So there is no point of continuing to transmit anything, right? Anything that we transmit now is useless and we should actually stop right away. So we can do that only in the case of collision detection. Okay, طيب. The more important بقى question and the tricky question is, so if we detect collision, we stop proactively, which is good. So when we stop, what we do بقى is that we go back بقى to the back off procedure, and we اللي هو بقى الكي, we generate بقى a random number in the window from 0 to 2 to the power k minus 1, and so on. We engage into the back off procedure. So we engage at the back off procedure time t4 على طول, okay, which is proactive. Type, is this good or bad? This is actually good because this makes A proactive. Because the other alternative, let's see, if A finishes a time here t5. This is this is a very tricky question now. If A finishes at time t5 here, okay, before it hears the collision. Now, there are two questions now. If it finishes at time t5, does that mean that the collision did not happen? Or the collision happened already? If A finishes transmission of the frame, يعني the frame is too short, the frame is very short, and it finishes the transmission here, okay? So does that mean that the collision did not happen? Or ايه؟ يعني معناها ايه يعني? Does that mean that the collision did not happen? Did it happen or not? It did happen anyway. صح, it did happen anyway. It happened actually at the very first bit of the frame. The first bit actually collided. Okay, so if you finish any time before T4, okay, that doesn't mean that the collision did not happen. The collision happened already. The collision happened already. Just the fact that you did not hear it, it doesn't mean it did not happen. Yes, Daniel. The vertical line here indicates the time. The vertical line indicates the time. The horizontal line indicates the space or the location, the relative location of these nodes on the transmission line. So A, okay, this is the time that A can send or feel that other nodes are sending. Okay, so A here knows that it started to send. Node A here listens to the signal from C at this time. Okay, so if now what we are discussing is that if the frame is too short and A finished sending at time t5, first of all, that doesn't mean that the collision did not happen. The collision happened actually here at the very first bit of the frame. Okay, So the collision did happen. The other question بقى here is that if A finishes transmission at time T5, okay, and the collision happened, but of course I finished transmitting the frame before I feel that the collision happened. So what should I do now? What should A do now? Wallahi, as far as I'm concerned, I'm done transmitting the frame. So خلاص, I will move on. I will move on to the next frame. Okay, and I will see if I have another frame. I will sense the channel, and then if I found the channel busy, so what will happen to that frame now? What will happen to that frame? This frame is done transmission. خلاص. Okay, even though the collision happened, or I felt the collision happened after. Okay, but this frame, for as far as I'm concerned, has been finished. Okay, so does that mean that this frame is gone? لا خلاص يعني what will happen is that I will have to wait for a long time to see whether or not I receive an acknowledgement. If I don't receive an acknowledgement, then and only then I will retransmit that frame. So I will engage again in back off. But when in a much later stage, when I do not receive the acknowledgement. Okay, so in other words, collision detection is good because it makes the node proactive, okay, in dealing with the collision. It's good, okay. If there's no collision detection, the nodes will have to wait for a longer time until the timeout happens and it does not receive the acknowledgement, in which case it will retransmit. But here, I can actually stop transmitting and I can engage in back off right at this point. Okay, so collision detection is good, but the other comment, which is more important here, that spending more time in transmission is also good. Spending more time in transmission is also good, because if I spend a short time in transmission, I will not have enough chance to detect the collision if it happens. Okay, so I should spend enough time in transmission, okay, until the frame fills the entire line, okay, and then if a node tries to send by mistake, I will detect the collision before I finish transmitting the frame. Okay, so when I start transmitting here, I should actually spend enough time. So if the worst case scenario that node D here, node D, okay, tries to send, and when it sends here, I will listen to the collision at this point. Okay, so this is the worst case scenario. So in fact, I should spend enough time in transmission until here. Why? Because if any node on the line tries to send, I will detect the collision before I finish transmitting the frame. So why this is good? Because it makes the node proactive in dealing with the collision. If I detect the collision, then I can stop transmitting, and I know exactly that the frame is wasted. I don't have to wait for acknowledgement. I can engage right away in the collision avoidance or the back off procedure with regards to collision. ماشي كده يا شباب. So collision detection is good. Unfortunately, it's only possible for the case of wired channel. So we need بقى to try to study or to characterize what is the condition on the transmission time, okay, that makes the node proactive. So now what we're trying to do is to make, so let's say this is time t6, okay. So what we're trying to do now is to make the frame transmission time greater than or equal t6 minus t1, okay. If that condition is fulfilled, then if any node on the line sends a frame by mistake, which means that the collision will happen, in that case, I will be able to detect the collision before I finish transmission. And that will make node A proactive in dealing with that collision. ماشي؟ Not بقى the 100 meter. The 100 meter actually comes from this, and also another very important phenomenon that we have discussed in network 1, okay, which we have given to you as a fact, which means that we told you that the minimum frame length for Ethernet was 64 bytes, if you remember this, okay. We have given this to you in network 1, and we told you take it as a fact, okay, without giving you why or the reason behind this. This is in fact the reason behind this. The reason behind this is that for wired network, Ethernet is for wired networks, collision detection is possible. So if collision detection is possible, we need the nodes to be proactive in detecting the collision before they finish transmitting the frame. Okay? Type. So again, where did we get this number from? Okay, what is the from this example here? Let's see, what is T6 minus T1? What is T6 minus T1? If A tries to send, right, and then D started to send after, let's say that this is time مثلا T7, okay. Time T7 is when the signal from A reached D, right? If this signal reached D and D senses the channel after T7, it will find it busy, صح? Okay? So D will not send. But imagine if D senses the channel right before T7, يعني 1 nanosecond before T7, okay? Then it will feel the channel is idle, right? Forget about C, forget about C. Yani see, this yellow one is not there. It's not in the equation. I'm talking about the worst case. The worst case is when D is in the position of C, which means C is not sending. D is the one that tries to send. Okay, so D will feel the transmission from A after, at time T7. Okay, so if D senses the channel right before T7, it will feel that the channel is idle, okay? It will try to send. When it sends, the signal will travel all the way back to A, okay? And then A will feel it here, which means that now the transmission time needs to be more than T6 minus T1. So what is that T6 minus T1 here? T6 minus T1 is the time that the signal from A, reaches all the way to the end of the line. What is that time? What did we call that time, ya shabab? What did we call this time? The time that the signal travels propagation delay, yes. So this is the propagation. So here, so this is a T propagation. Okay, طيب. And this time, يعني from here all the way to here, that's another T propagation, right? Right? So which is the time that the signal from D goes all the way back to A. That's also propagation time. Which means بقى simply here that T transmission should be greater than or equal to 2 propagation delay. اوكي؟ مفهومة دي؟ مفهومة ولا مش مفهومة؟ ابراهيم مفهوم ولا مش مفهوم؟ مفهومة؟ Okay, good. Okay, so this transmission time needs to be greater than the time that the signal propagates all the way to the end of the line, which means this frame will fill the entire line. And then if it ever happens that the node at the other end of the line sends by mistake, which means the collision happens here, I can feel it before I finish transmission. Okay, so this is the condition, and this condition is valid again when collision detection is possible. ماشي؟ طيب. So why? Because any question about this? Because this is an important parameter now. In this example, we will take it back with some numerical values. Yes, Daniel. Analysis here. So this example shows you why. So for an Ethernet network using SISMA CD, it has a bandwidth of 10 megabits per second. So this is the typical bandwidth, by the way, for UTP اللي هو Cat 5. Okay. So if the maximum propagation time, is 25.6 microsecond. Okay. So what is the minimum size of the frame? So let's see here numerically, how does this look like if that propagation delay is 25.6 microsecond? Okay. So what is the condition? The condition now is that the T frame is greater than or equal to 2 times 25.6 microsecond, which is 51.2 microsecond. Okay, so this frame transmission time should be greater than 51 microsecond. This is for the case of UTP Cat 5 for Ethernet 10 megabits per second. طيب, what is بقى the transmission time? The transmission time is ايه يا شباب؟ اللي هو transmission latency يعني. What is that transmission latency? How did we define the transmission latency? محمد جمعة تعرف? What is the transmission latency? محمود جمعة قصدي، محمود جمعة اتفضل. محمود جمعة, do you know what is the transmission latency? اللي هو transmission latency. احنا عرفنا the transmission latency ان هو ايه بقى؟ transmission latency is هو كانت ريشيو بسيطة يعني. ايوه محمد باهري اتفضل. محمد. Yes, okay, so it's the length of the frame divided by the bandwidth. What is the bandwidth? The bandwidth of اللي هو 10 megabits per second. Okay, which means that the minimum frame time, the minimum frame length بقى, the length of the frame equals to 51.2 microseconds, so times 10 to the power 6, okay, multiplied by 10 اللي هو bandwidth times 10 to the power 6, okay, which means it's 512 bits. 512 bits is 64 bytes. If you divide it by 8, 512 bits is actually 64 bytes. If you go back to network 1, you will see that what we have told you is that the minimum data length for the data in the network layer is actually 44 bytes. طب دي جت منين 44 if it's 64? Because this 44 plus the header length from the network layer, the header length from the network layer is 20 bytes. So this means that the frame length, because the frame coming to the data link layer is the data plus the header from the network layer. Okay, so 64 is actually 44 plus 20. Okay, so this is the minimum frame size. So the minimum frame size for Ethernet is the time that the node should not finish transmission before the frame fills the entire line. Okay, so the frame fills the entire line, and if it ever happens that any node on the line tries to send, okay, I will fill the transmission of that node before I finish the transmission. Okay, which means that the time for frame transmission should be greater than or equal to double the propagation time. ماشي؟ Any question يا شباب? Any question here? Since we are, so this characteristics is this this parameter is very important for, again, for SISMA CD when collision detection is possible. طيب, so this is the flow chart for SISMA CD, okay? And remember, this is for CD, because for CA it will be totally different. We'll talk about that. So now, similar to what we have done for Aloha, now the difference is that here I will apply some persistence strategy here. I will apply any one of the persistence strategy to know the eligibility for transmission. Eligibility for transmission is by sensing the channel continuously until I find that the channel is idle, or I sense the channel, and once the channel is idle, I generate a random number, and then the random number is less than P. In that case, here at this point, I will be eligible for transmission. Okay, so whatever the persistence strategy here, I'm eligible to transmit. So what happens is that for SISMA CD, I will start transmitting, okay? While I'm transmitting, I will keep sensing the channel, okay? I will keep sensing the channel. Why? Because this is bad, the difference between Aloha and SISMA CD protocols is that while transmitting, I will keep sensing the channel so that if there is a collision, I will detect it. Okay, so while I'm transmitting, I will sense the channel. So one of two events might happen in that case. Either I finish transmission or a collision happen. Okay, so whichever event happens, I will stop. Okay, so if any of these two events happen, I will stop. So when I stop, I will ask myself, did I stop because the transmission has finished, or did I stop because a collision happened? Okay, so if I stop because a collision happened, then I should engage in the back off procedure. The back-off procedure from here is very much similar to Aloha. Very much similar to Aloha. So this back-off procedure is very much similar to Aloha. ماشي? There's no change. ماشي? That happens if the collision was detected. If the collision did not happen, خلاص I finished. Everything is fine. طيب, when a collision happens, another difference here is that if any node detects the collision while it's sensing the channel, it sends a jamming signal. Okay? Any node. Like, for example, if detecting the collision, we should try to make everybody proactive about dealing with that collision, which means that everyone should engage into the back-off procedure right away. Okay? If you are transmitting, stop. Okay? If you are not transmitting, you should engage in random back-off. You should wait until the channel is clear, and then you should try back to go back to the persistent strategy. ماشي كده؟ طيب. So sending a jamming signal again is facilitated because of the fact that we detect a collision. The tricky question بقى, this is a bonus question. I'm telling you now that we are trying to, we detected a collision. So now the channel here, is in a state of collision. And I'm sending a jamming signal on the channel. Okay? While the channel is in a collision state. How can I do this? How can I do this now? How can I send a signal on a channel that's already engaged in collision? Yes, Daniel. No. Here, immediately, once the collision happens, any node that detects the collision will send the jamming signal. على طول. It will not wait for anything to be cleared. حسين تفضل. برافو عليك. برافو عليك. So the channel, when it comes to the frequency, there is a specific frequency range for the data. Okay? So the collision happens at this frequency range. Okay? If a node sends a jamming signal, it will in fact send a jamming signal on a separate frequency range. We call it the control frequency. Okay? So that's why I told you that when the node here tries to send, it will transmit and receive. Receive what? Okay? When the node sends, it should receive. So send, we know that it's sending the data, but receive what? Listen to what? It actually listens to the jamming signal. While the node is transmitting, it actually listens to this frequency range, so that if any node sends a jamming signal, it will listen to it. It will get it. ماشي? So this jamming signal is sent on a separate frequency range so that it does not collide with the data transmission. So data transmission can have collision. The control signal now, okay, it's on a separate frequency, so there is no conflict. Once a node sends a jamming signal, all the nodes will be informed about the collision, okay, and all of them, they will engage in the back-off procedure. This back-off procedure, as we have talked before. So you have K, and then from K you create or you generate a range 2 to the power K minus 1, and then you try to generate a random number, okay? So random number in this range, and then you multiply it by the propagation delay. And this should be the wait time for any node before it goes back to here to sense the channel again. Okay. Any question in that part? So the main branch is significantly different compared to Aloha because of the fact that we can sense the channel before transmission. And actually, even if I'm trying to transmit, I should also sense the channel to try to detect the collision. And if the collision happens, I should send a jamming signal. Okay? تفضل. That's يعني a good question. The answer is that it's not always possible. Why? I will tell you why. Because if you send very high power, okay, what will happen is that the transmitted data will cause some kind of interference to that high power signal, right? So if you have collision, as we will see in a minute, if you have collision in fact is high power. Okay, so you need to be higher than the high power, and you don't know whether there are 2 nodes engaged in a collision or 3 or 4 or 5. And I will yes, and this will become clearer in the next slide now. Okay, so the answer is that no, it's not good and it's not possible. So okay, so how do I detect the collision? For the case of wired, and this is very important, for the case of wired, what will happen is that we have a shared line. Okay, we have a shared line. Okay, so if a node here starts to send, assume that the transmission signal will have a power of P. Okay, so what will happen is that this node will send a signal, okay, and the signal will go through the line. The good news is that since we have a guided medium, a wire, okay, the power here is P hat, which is almost P, which means that the attenuation that happens to this signal is negligible for the case of wired network. This is very good news. Why? Because this means that if any node in the middle tries to send another signal, I will have two superimposed signals now. What will be the power level at this point? It's almost 2p. Okay? And if there are actually 3 nodes, I will find this 3p or 4p. Okay? Why? Because the signal does not lose significant energy in the guided transmission. ماشي؟ طيب, so this channel will have now 3 states. Will have 3 states. The first state is that the channel is idle. Okay? Channel is idle can be detected easily, that the energy level or the power level, okay, is almost zero. Is almost zero. Why exactly not zero? Because there might be some noise on the line. Okay, so it's like delta P مثلا. The second state is that the channel is busy with one transmission. Okay, this means that the power level on the channel is almost P, which is the transmission power. The transmission power from one node is P. Okay, so the power level is almost 1P. طبعا plus or minus delta P, which is the noise level. ماشي. Number 3, that the channel is in collision state, which means more than one transmission. يعني 2 or 3. In that case, the power level on the line will be greater than 2P, okay, again plus or minus delta P. So the good news is that on guided medium, the distinction between these three states is possible with very high accuracy, because the difference between delta P and P plus or minus delta P is big on the wired line, and the difference between 1P and 2P or 3P or 4P is also big, and it's almost deterministic. يعني معنى ان هي it's not dynamic, it doesn't change. Okay, so the distinction between these three states is perfectly possible for the case of wired networks. That's a very good news. Okay, تعال نشوف بقى for the case of wireless. For the case of wireless, we have one node and we have other nodes around it. Okay, so when a node tries to send, what will happen is that the signal, of course, the shared medium here is the air. So when a node tries to send, the signal will dissipate through the air, okay, in 360 degrees. Okay, so what will happen now is that the signal, when the signal dissipates through the air, remember that the signal will get to some obstacles, like let's say we are in a lab and there are some objects and stuff like that. So this will cause the power level at different points around the nodes will be very, very different. Very different. ماشي? So this will make the accuracy of detecting these states, so detecting these states now will have lower accuracy. Why? Because the power level here is different from here, because when the signal dissipates in 360 degrees, it loses the power in different directions with different rates. ماشي? So relying on the power level for the case of wireless is tricky. So it turns out that detecting the busy from idle, okay, can experimentally can happen with some acceptable level of accuracy. But detecting the busy from the collision, P from 2P, okay, is very low accuracy. Very low accuracy. So ماشي يا شباب, anyone who's not following? So for the case of wireless, the power level changes a lot in the area around the node that tries to send. So this means the accuracy of distinguishing between these three states is will have low accuracy. Okay, so this means that we cannot rely on collision detection in that case. Collision detection is not possible. Since collision detection is not possible, okay, so we will try to avoid the collision because the collision detection is not possible. ماشي كده؟ Any questions so far? So for the case of wired, good news, it's possible. Accuracy is very much acceptable, very high accuracy, and everything is fine. For the case of wireless, accuracy is low, especially to distinguish between busy and collision. ماشي؟ So that's why for the case of wireless, we can do a collision avoidance. We cannot do collision detection. We cannot detect the collision. So what we will do is that we will have, طبعا here, we send the frame, and if it times out, if we don't receive the acknowledgement, we know that the frame has not reached and there was a collision, so we transmit again. So this phase actually exists in all the techniques we talked about before. حتى in SYSMA CD and in Aloha, this phase exists. But for collision avoidance, we will have two extra phases, ماشي, to avoid the collision. Not detect it, of course, because detection is not possible. So we want to avoid the collision. طيب. So how do we do this? So in the first phase, what will happen is that we will use the one persistence to try to see whether the channel is busy or not. هتقول لي طب ما يعني انت لسه you are telling us that sensing حتى يعني detecting that the channel is busy is not يعني accurate. Yes, that's true. The accuracy here is يعني let's say the accuracy is around مثلا 70-80% to detect that the channel is busy. Detecting that channel is busy معناها ايه؟ That the power level is above delta P يعني. ماشي؟ So that highly depends on many things, whether there are obstacles or not, whether the node that tries to sense is in the range of the other node that tries to transmit. يعني there are many factors. Okay, so there is a chance that if I detect that the channel is idle, that this is a false alarm. Okay, so detecting the channel is idle here has some level of accuracy. It might be correct or wrong. I don't know. Type. So what do I do now? If I detect that the channel is idle, I will not يعني, admit that the channel is really idle. What I will do is that I will wait for a fixed time. All the nodes will do that. All the nodes that try to sense the channel, they will say, oh, okay, so I will wait for IFS. IFS stands for inter frame spacing. Okay, so they will wait for inter-frame spacing, and then they will sense the channel here again. If you sense that the channel here again is idle, so this means that at the first time it was idle, and I waited for some time, and then I detected that the channel is also idle. This means that يعني, this increases the accuracy now from 70% to almost 90% مثلا, right? So I sensed that the channel is idle, and I waited for some time, and I sensed the channel again, it becomes idle. So this means here that the accuracy has raised now, and I'm more confident that the channel is really idle. Okay, the channel is idle. Let me fire and send the frame. That's not a smart way of doing it, because the problem is that this interframe spacing is fixed. If all the nodes they do the same thing, they will wait for a fixed time. All of them, they will fire and transmit, and the collision will happen here. Okay, so we should be smarter now. So we are trying to be very conservative. We are trying to avoid the collision because we cannot detect it. So what do? After we wait for interframe spacing and the channel is still idle, we go to the second phase. In the second phase, we call it a contention phase. Okay, so we have gone past the interframe spacing phase, and now we are getting into the contention phase. In the contention phase, what we do is that we do similar to the exponential backoff procedure. Even though collision did not happen, صح? But the default behavior is that we will engage in a procedure similar, very much similar. So this one is very much similar to the backoff. Very much similar to the backoff procedure. Okay, to try to avoid the collision. ماشي? Because again, if the collision happens, we cannot detect it. Why do I say it's almost similar, but it's not exactly similar? So it's similar in the fact that, again, there is a parameter k, okay, which again starts with 1, and then it increments to 2 and 3 and 4. And then we generate a random number from 0 all the way to 2 to the power k minus 1. So we do everything as if there was a collision, even though there was not. ماشي? So we generate a random number in this range, and then we wait for a time equals to the random number times the propagation time. So this random number here happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this time happens to be 9 times the propagation time. Okay, so the node should now wait for 9 times the propagation time. So what the node will do is that first I will generate a random number, and then I will wait for, this is the wait time. This part is very much similar to the exponential backoff. ماشي؟ طيب, what do? I will start a timer. ماشي? That will fire after the 9 propagation time. Okay? طيب, when I start the timer, خلاص, I forget about it? No. What will happen is that after each propagation time here, I will sense the channel again. That's different from the backoff procedure. So here number 3, sense after each propagation time. After each propagation time, sense. Why? Because if I sense the channel during this time, the channel should be idle. If I sense that the channel is busy, does it make sense to continue? ما خلاص, the channel is busy معناها another node has detected that the channel is idle, and it generated a random number, and this random number happens to be less than 9 the propagation time. So this node tried to access the channel at this point. Okay, so I will find that the channel is busy. Is there any point of continuing to back off? Man, there is no point. خلاص, man, the channel is busy. Okay, So this part is different from the back off. What will happen now is that when a node detects that the channel is busy, it will خد بالك بقى not stop the timer, it will pause the timer. So I will not continue into the back off. I will pause the timer and then خلاص I will go back بقى to sense the channel, and I will wait for the channel again to be idle. I will go back here. I will go back to the sensing phase. ماشي? So if I sense that the channel is idle during the back off time, I will pause the timer and then I will go back from the beginning. The question is now, why do I pause the timer and not stop the timer? Any guess? Why do I pause the timer and not stop it? Any guess يا شباب? Why not stop the timer وخلاص? Yes, Daniel. Yes, very good thinking. Very good thinking. So I pause the timer. Why? Because I don't want to repeatedly start the timer and then stop it, start the timer, and I will never have the chance to access the channel. So if I pause the timer, then next time I will have higher priority, okay, in gaining that. This is similar to ايه بقى? To مثلا in real life, when you go and stand in a line مثلا, waiting for the teller or waiting for some event to happen and then when you get close, every time you get close they tell you no خلاص we closed at this point, come back later. When you come back later, you come in the back of the line and then you wait, okay, and before you get your turn they tell you no sorry خلاص we closed and come back later. So when you come back later, you wait at the end of the line again. No, that doesn't make sense. Okay, so if I wait in the line to access the channel, okay, and I did not access the channel, I should have more priority next time صح? That's logical. So that's why we pause the timer, not stop it. So that pausing this timer will maintain the fairness in that case. Okay? So this is the contention phase, which is slightly different from the back-off procedure. And as you will see بقى in the flow chart, that this contention phase replaces completely the back-off procedure. So this is the first phase. In the first phase, we use the interframe spacing. The interframe spacing allows us to increase the accuracy of detecting that the channel is idle. Okay? هنا بقى there is a very interesting statement that this interframe spacing, in fact, in normal cases it's fixed, but can it be variable? In other words, can I have interframe spacing 1 which is less than interframe spacing 2 which is less than interframe spacing 3 and so on? And what does this imply? If a node waits for interframe spacing 1 and a node waits for interframe space, so this is node مثلا X and this is node Y. Okay? So what does that mean? This means that in fact node X will have higher priority, صح? Because it waits for a shorter time. So it actually senses the channel quicker, which means it can access the channel faster. So this means that node X will in fact have higher priority. So this is a very interesting phenomenon now. I can use the interframe spacing to provide some discrimination between the nodes. هتقول لي بقى, why do we need to provide discrimination between the nodes? When did we talk about discrimination between the nodes يا شباب? Where do we apply this? حد فاكر? When did we say that discrimination between the nodes is actually a good thing? It's not a bad thing. حد فاكر؟ Anyone remembers? No. لا, هو احنا we talked about this. Yes, for quality of service. For quality of service, as we said that some nodes may have video streaming, some other nodes may have web browsing, صح? Other nodes have audio. So we can provide priority distinction between the nodes. This is as part of quality of service. So we talked about quality of service in the network layer, صح? When we talked about differentiated service code point, if you remember, DSCP, right? So that's another level from the data link layer where we can provide quality of service. So this is part of a standard, because here we're talking about wireless. All wireless Wi-Fi standards, they start with a 802.11, right? So we all know that. So in 802.11 we have A, B, C, AC, E. So 802.11e, okay, is a Wi-Fi standard that provides quality of service. And the whole idea is just to introduce different interframe spacing. And in fact, why stop at this point? So we can provide different contention window as well. Okay, so I can use different interframe spacing and different contention window to provide different priority classes for the nodes. So if a node sends video streaming, I will put it in the first class, which has IFS1 and contention window 1, and so on. So we had the course اللي هو 482 I think, اللي هو CMPE. This course is called Multimedia Networks. This course, half of the course talks just about this, just about the 802.11e and what is the distinction between all the. So this actually deserves a separate discussion, very, very long discussion, to try to see how we can use these parameters to provide different distinctions between the node. And I would not have talked about this if the book does not mention فكرة use the IFS for priority So using IFS, different IFS or different contention window can be used to provide priority schemes for quality of service. ماشي? Any question about this part? طيب, the other thing is that in SYSMA CA, if the station finds the channel busy, it does not restart the timer, which is what we talked about. Okay, it actually pauses the timer. Okay, and then in the next phase it will resume the timer so that it gains higher priority in the channel for the next time. So it ends up that the flow chart بقى uses the contention procedure and the IFS phase as the main branch. Okay, and as you can see here, the backoff procedure has been completely eliminated. Why? Because it was replaced as the main procedure for contention. ماشي؟ يبقى here for wireless backoff procedure is not needed because the contention procedure implies or contains inside it backoff procedure. مفهوم يا شباب؟ So what will happen is that a channel senses that a node senses the channel. It finds that the channel is idle. It waits for interframe spacing. It finds that the channel is still idle. Okay, so it engages in the contention phase. So this is phase 1. This is phase 2. This is the IFS phase, and this is the contention phase. In the contention phase, the node will generate a random number similar to the backoff procedure between 0 and 2 to the power k minus 1, right? And then it waits for r time slots. But here بقى, I should actually, the flow chart should be corrected a little bit, because this here, during this r time slots, I will not just wait. I have to again sense the channel again, okay? And if the channel becomes busy, if the channel is idle, I will go. If the channel is busy, okay, then I will if the channel is busy, what do? I will pause the timer, and then I will go back. Here. Okay. So this has been abstracted by this block, but in fact, this block is just every time slot, it has to check if the channel is busy. If the channel is busy, then it pauses the timer and goes back from the beginning to sense the channel. If the channel is idle, then khalas, it goes and waits for another time slot, and then it senses the channel again, and so on. Okay. Once the backoff procedure, or sorry, the contention window finishes, which means the timer will fire, then and only then, after all these precautions that I have done, and I made sure that the channel is idle completely, then I will have the eligibility to send over the channel. So when I send, I will wait for a timeout, normal, like the normal phase, and then if the acknowledgement is received, then I'm done. If the acknowledgement is not received, then I will not do back off, because in any case I will do the contention phase. So the only thing I need to do when I don't receive the acknowledgement is just to increment k. That's it. Any question here, Shabab? So for wireless, the bad news is that I cannot detect collision, so I can only avoid it. So avoiding the collision happens in 2 stages. The first stage is the interframe spacing. If I wait for interframe spacing and then again I find that the channel is idle, then I will engage in the contention phase. In the contention phase, I generate a random number and I wait for r time slots. Every time slot, I will have to check again. If the channel is busy, I pause the timer and go back from the beginning. If the channel is idle, I go to the next time slot until the timer is fired. When the timer is fired, then and only then I can send the frame. So all these precautions are done to avoid the collision. Okay. Does that mean we can eliminate the collision? Never. You cannot eliminate the collision at all in the case of contention protocols or contention-based protocols, because we do not have centralized controller. So next time we need to talk about controlled access, where we can eliminate collision completely. In all the procedure, in all the protocols we talked about, Aloha, we talked about slotted Aloha, we talked about SYSMA, we talked about SYSMA CA and SYSMA CD. All of them, they try to reduce, avoid the collision, reduce the probability of collision, but never eliminate it, because they cannot. The only way you can eliminate collision is by having a centralized entity, a centralized controller. That's what we need to talk about next time, inshallah. Okay? Any questions?